Hello everyone, I am Ishika of BSc third year non-medical from the Anand Mahila Mahavidyalaya. Today we are going to discuss about the topic chain lengthening and shortening in aldoses. So let's start our topic. Today we are discussing about that topic. Chain lengthening and shortening in aldoses. Okay, so firstly we study the mainly chain lengthening. What is about it is also called name, it is a name reaction calledGliani-Fischer reaction, or you can say thatGliani-Fischer synthesis. Since synthesis is because at last step there is a reaction that is synthesizes. Okay, its mainly function is that lengthening of carbon chain. How it is performed? Let's see. Its main function, as we know, is a conversion of aldopentose into aldoexose. Okay. Then what is aldoexose? Aldoexose is 6-carbon compound which is converted from aldopentose. And what is aldopentose? It is 5-carbon compound. Okay. Why there is aldo? There is aldo because it is having aldehyde group in first carbon. And why there is aldo? Same reason. Having aldehyde in first carbon. Okay. Let's take an example. It is nothing less than arabinose converted into glucose. It is glucose, nothing else. Let we show a structure to you. It is a structure of aldopentose. Okay, this is converted into aldoexose as we study earlier. How it is converted, you can see. We further study a mechanism of it. Let's see. First, second, third, fourth, fifth. There is 5 carbon. And there is 1, 2, 3, 5, 6. There is 6 carbon. Okay. Let's see mechanism of it. During its mechanism, number of steps are performed. Firstly, reaction of we react aldose with hydrogen cyanide. Then due to this reaction, cyanohydrine is formed. Okay, then the cyanohydrine is hydrated. Cyanohydrine is hydrolyzed. Okay, cyanohydrine is hydrolyzed. Then we obtained mixture of 2 acids. Then the heat actions. Then we put that. Then we heat that reaction, and formation of lactones is there. I know you don't understand by this, so let's do with it example, or you can say that with mechanism. Let's see its mechanism. Okay, this is, as we know, we convert aldopentose into aldoexose. So let's start it with our main compound, that is aldopentose, that is 5-carbon compound. Okay, I explain everything in it. Okay, in this, hydrogen attack to this oxygen, as hydrogen is positive or you can say that it is proton, and this oxygen is negative, or you can say that it is having lone pair. As we all know, this hydrogen attacks to this, and this cyanide ion, this is not cation, this is ion. This ion attack on this. Okay. By this reaction, cyanohydrine is formed, as I tell you earlier. Cyanohydrine is formed. Why this name is as cyanohydrine? Because cyanide group is there. In this, as we study earlier, this is hydrolyzed, so we add 2 moles of water. In this we can see that 2 to 4 hydrogen and 2 oxygen. Okay, 4 hydrogen and 2 oxygen. Then this nitrogen group, react with this 3 hydrogen and ammonia is out. And this 1 hydrogen and 2 oxygen react with this carbon, because this is positive and this carbon react as negative, because after losing nitrogen, this there is lone pair. Understand? Then ammonia is out. Then we get this, as there is COOH, so we get this acid. Now we heat this acid, and the water molecule is out. How? Let's see. This hydrogen, or you can say that proton, react with this ion and water is out. Understand? Then after losing hydrogen, there is Fischer projection. And what is it? It is basically the reaction of oxygen to alternate, you can say that alternate carbon chain, or you can say that in carbon chain the alternate carbon makes bond with oxygen. This is called Fischer projection. After that we hydrolyzed it. We add 2 proton, and as we know there is lone pair, then 1 hydrogen, or you can say that proton, 1 proton react with this oxygen. Okay, and we also add sodium borohydride, or you can say that sodium amalgam. It is none other than as catalyst. Then the question arises, what is catalyst? Which speed up the reaction. Okay. After reduction is done, then we get our final product, that is L2 pentose. You can see that there is 1, 2, 3, 4, 5, 6. There is 6 carbon chain. That is aldo pentose, 6 carbon. This is known as glucose also. This is all about the Killiani-Fischer reaction, or you can say that Killiani-Fischer synthesis, because at last there is synthesis of compounds, right? if we conclude this, we can say that aldopentose is converted into aldohexose. 5 carbon compound is converted into 6 carbon compound, and the reduction of ammonia and water is there in the presence of hydrogen cyanide, water, sodium amalgam, and reduction is there step by step. Let we now study our next topic, that is shortening of carbon chain. This is mainly of two types, that is first is rough degradation and second is whole degradation. Let's study one by one. First is rough degradation. In this, many methods involve, you can say that many steps involve. First, there is oxidation of starting aldose. Aldose into corresponding aldonic acid. Its main function is this. Then this acid is converted into calcium salt, which further treated with Fenton's reagent. And what is, now question arises, what is Fenton reagent? It is H2O2 in presence of ferric ion. What is H2O2? Hydrogen peroxide. And when these both are present, this whole known as Fenton reagent. In this, this reaction is done, acid converted into calcium salt. Why? To get lower aldose, because its main function is degradation. Degradation means come on lower aldose. Understand? Let's see its mechanism. Mechanism of rough degradation. In this, our first compound is aldoses, which is glucose. Firstly, as we studied earlier, oxidation of aldose is done, and once it is done, we get a acid, that is gluconic acid. And why this named as gluconic acid? Because acid is present there. Then it is treated with lime. And what is lime? CaOH twice. Why this treated with lime? Because as we all know, salt, acid plus base give rise to salt. And here also acid, we treated it with base, that is lime, and we get a calcium salt, as you seen there. And calcium ion is protonated there. Then this calcium salt is treated with hydrogen peroxide in presence of Fe+3 ion, This is called, as we studied earlier, Fenton's reagent. Then we obtained our final product, that is aldopentose. In this 1, 2, 3, 4, 5. There is 5 carbon, and we started with 1, 2, 3, 4, 5, 6. 6 carbon. So we can see the degradation. Let's start our second method, or you can say that second type, that is whole degradation. In this, aldose is converted into oxime, or you can say it's oxime. It's oxime means aldose oxime में convert हो जाता है. By which reaction? Reaction with, when this react with hydroxyalamine. Then oxime is treated with acetic acid. Acetic anhydride. This is treated with this. In this, oxime gets hydrolyzed. You all understand this by mechanism. We study later. This hydrolyzed into nitrile, and same time this various hydroxyl group are acetylated, sorry. Okay. Then this react with Tollens reagent. Then question arises, what is it? Tollens reagent is AgNO3. It's named as Tollens reagent. Why we use this? Because to degrade the carbon atom, or to contain less carbon atom in final product. Let's move to the mechanism. Whole degradation. Our first product is aldoses. As you studied earlier, this is also called D-glucose. This is studied with hydroxylamine. In this H2 treated with oxygen and water is move out. This converted into oxime. Then it is treated with this, and it converted into acetylide cyano compound. Why it is cyano? Because of having cyanide group. Okay. Then it is treated with AgNO3. And what is AgNO3? Tollens reagent. In this reaction, hydrogen cyanide and acetic acid is removed out due to this. And why we add this? This act as catalyst. And by this reaction, we obtained our final product, that is aldopentose. In this, we have 1 carbon less than our starting product. In this we have a 5 carbon, and in our starting product we have 6 carbon. So here also you can see degradation. So this completes our today's topic. Thank you for watching my video.